Hi everyone, I'm Joseph. I've spoken a lot this week, and this is my last one. So, thank you. Yeah. So, actually this one's a lot easier too, because in the pre-con training on Tuesday, I also talked about the event reactor with a completely different set of slides. I wrote them both within the same week, and they look about the same, and I did them completely separately and didn't realize until this morning how almost identical they are. So if you're there on Tuesday, this might be a good time to find another session. Otherwise, let's go ahead and move forward. So we're going to talk about the reactor system today. I'm really excited about the reactor system, and every time I get more and more into it, I get just more and more excited about it. This is one of the really powerful things about Salt. This is one of the things that really separates us from a lot of other tools out there that are otherwise similar in other ways. Salt, you guys heard this in the keynote from Tom. Salt did not start off being a configuration management system. Salt started off being a remote execution platform. And one of the things that the Salt has always kind of been based on is this 0MQ bus. Have any of you guys ever dove into 0MQ internals? Or are you all sane? So 0MQ is one of those things that we really never could have done Salt without it. It did finally reach its limitations, which is why Tom has been talking a lot about rate. But 0MQ set up this bus for us that we're able to make use of for other areas. So first off, this bus, it's an open bus. We weren't initially really using it for Salt itself. It was there. We left it open for people to make use of. I don't know that anyone really made use of it before we came out with the reactor system. But we talked a lot about how you could make a system that would react to events if you wanted to. The only requirement really would be that Salt was standing up and holding open that road for it. Eventually, we did introduce the reactor system and start having Salt use the event system itself, and things started to get really, really powerful. Because previously with Salt, we had this idea of you issue a Salt command, it goes to a machine, it runs a command. In fact, a lot of Salt, if you guys have ever written modules, Salt has a whole lot of wrappers around command lines. And it takes those command lines, it parses out the output, and then it returns back something to you that's more useful. But there's still just one-off commands. States are nice because you can take all those one-off commands and orchestrate them into mini commands on a system, but you're still limited to that one tool set. Well, now we can execute the one-off commands, we can execute the states, we can do the things that we normally do with Salt and watch for events that happen when we do those things. And if something happens that we're looking for, then we can react to it and start off another process. And in fact, that process can go and do something that ends up kicking off another event that starts off another process. We can actually have the master and the minion communicate with each other asynchronously, carry on this entire conversation with each other. In fact, multiple minions through the master can carry on these conversations using this reactor system. So it's very, very powerful. It is now used very extensively by Salt. We were talking yesterday, I don't see Colton in here. Colton and I were talking about how when you start up the Minion, there's actually two events that are fired. One is called, I believe, just auth or Salt auth, and the other one is a namespaced event, and we'll talk about these namespaces in just a moment. And then there's a number of other things that happen while the Minion is running, and the master is constantly looking at these events. There's actually two event buses right now. The Minion is able to talk to itself, Minion to Minion. When I say Minion to Minion, I don't mean one Minion to another Minion. It's just to itself. And then Minion to Master. I imagine that Salt internally uses the Minion to self bus quite a bit, but other applications, we've been talking over the past 2 or 3 days over what might actually use the Minion to Minion bus, and we can't think of anything practical outside of Salt. But Minion to Master is it's very powerful. So that's what our focus is going to be on today. The structure of an event now, in this structure, appeared in not.17. Each event has, well, they've always had a tag and a payload, but the limitations on those were removed in not.17. The tag used to be limited to 20 characters, and when we started namespacing events, or namespacing tags, and realizing that we need far more space than that, that was expanded. So there's no imposed limit now on the tag length. Likewise, there's never been an imposed limit on the payload that can be sent across an event. The tag is there just to notify you that what type of thing, quickly notify you what is happening. It's like a newspaper headline. If you don't care what the headline says, then you skip over the article and move on to the next thing, right? Do you guys remember news groups? Anyone use those still? Yeah? Do you guys know why news groups exist? It's because back when they were introduced, everyone had email. I say everyone like there was a lot of people using the internet at the time. There wasn't. In fact, the internet as the internet was only about 2 years old. The ARPANET was about 20 years old. But the idea was people had 300 baud modems. They didn't have time to download these mailing lists. All they wanted to do was look at headers and see if the message was actually important to them. And so newsgroups were introduced as a server-side email system so that you could skip over the things you didn't care about. And this is kind of what a tag is like. It's just a quick reference to let the master know if what it's looking for is important. And if we want any specific details about something, we add it to the payload inside the metadata. Any questions so far on events? By the way, guys, feel free to ask questions. I love questions. It shows that you're listening and not asleep. And it also helps out other people understand something. So don't be shy. Whatever question you ask might help out somebody else. Okay. So listening events, this is something that we've actually had a test script available for a while called eventlisten.py. This allows the user to listen to events, see what's going on. They can listen on the Minion bus or the master bus. In the old days, you actually had to say which bus you were listening to and which socket file to listen to. And now we just assume that you're on the master using the correct socket file, and you just start up event listen, and it's happy. You don't necessarily have to use that script. You can write your own script that just accesses the bus directly. It's probably a lot easier to use the Salt built-in API, Salt Utils event, and listen that way. We'll go over that in just a moment. But for just for test purposes, let's take a look at eventlisten.py over this window here. Now, this script does not ship with Salt per se, unless your method of installing Salt is via Git, and for many people it is. The reason it doesn't ship is because it's in the test directory, and things inside that directory are for testing Salt before we package it up and ship out RPMs or debs to a distribution. So let me expand that a little bit. Sorry, guys. So the script, it's very simple. In fact, most of the script is just overhead and parsing out command line parameters, and there's some kind of advanced stuff in there for counting events and counting which minions are talking to you. And we can skip over pretty much all that and go down to, let's see. I skipped over the import Salt Utils event at the top. You can just assume that it's imported, and we have event equals Salt Utils event.get event. Very simple. It detects which type of node it's talking to. In this case, you would normally say master or minion. Those are the only two options for that. The sock directory, it's var run salt master or var run salt minion. The transport is 0MQ, generally speaking. Is anyone here using rate in their infrastructure? Okay, so we're going to want to change that over to rate when you call that. The rest of you, just go with 0MQ for now. And then any options that need to be passed over to the event system. And then we go down a little bit and we say, do an event.get event. And usually it says listen equals true. But it's going to just sit there and query the bus and look for events, look for things that are happening, and then print them out to the screen. And the rest of this is printing stuff out to the screen. So let's go ahead and run that guy up. I'm already in the test directory, python event listen.py. It starts off by telling us which socket we're going to be using, var run saltmaster, master event pub, blah, blah, blah. And I'm going to hop over to this window here. And, well, we'll get back to that in just a moment. I want to get to the slide that actually shows the commands. Hopefully I put in a slide that shows commands. I didn't. Let's show some commands first, okay? So salt. And then I've only got one minion. I'll just refer to it by that. Event dot, there's fire if you're talking from minion to minion, minion to self. But since we're talking to the master, it's fire underscore master. And then you give it a payload. I'm not going to do a really big payload here. And you're not normally going to be using the event system from the command line like this, which is good because it's kind of, you have to give it a full data structure, and JSON is the way to do it here. But guess what? That's a correct JSON data structure. So we'll just go with that for now. And we'll just say my custom event as the tag to look for. So I'm going to go ahead and fire that off. And I'll hop over here and watch the event listener. You guys saw a lot of stuff come through. And don't worry, you don't need to worry about all of it. Let's go up a little bit to where we started. Okay, we have a job that was kicked off, and you guys see what the job was called. The fun function is event.firemaster. You guys can see the arguments that were passed in, which were basically nothing. And then a tag name. You see that there's a job ID there. We see the minions that it targeted, and then the actual target name that I used. I've only got one minion on this guy. It's just pointing to itself, so it only showed up on the TechHat master. If we scroll down a little bit, you'll see where it actually created a job based on that. And so now we have a tag that says salt/job/ the job ID and then new. And then something that Salt normally does on a regular basis is that the minion will regularly check in with the master and make sure that that it's talking to the right master and not talking to some man in the middle. You'll see that pretty regularly. If you guys were there on Tuesday, we talked about tuning and how to make those occur less frequently. We're not going to talk about them here. We go down a little bit and we see the actual event fired. So the tag my custom event, we see data, which was empty because we didn't pass it anything real except for an empty dictionary. And then we see a number of other events that are actually coming through afterwards that also are particular to that. And then the return data going back to the master came back as an event. So you see there's actually a number of events that were generated by this, including the one that we actually care about. And so what we want to do is be able to react to that event and do something. Well, we won't do anything special here today, but we want to be able to do something when we see events like that. So, yes?
My boss has expressed some concern that there's absolutely no authentication on these IDC other than socket permissions.
Right.
Is there any thought given, has there been any thought given to having some sort of auth framework on them to permit only certain users to listen for certain classes of types?
So the question here is there is, he's worried about authentication on the event bus, about arbitrary people being able to listen to the socket and talk to it. I don't have an answer for that. You saw that there were a number of events that were generated along with it that the Salt takes care of on its own. And I can't imagine you'd get very far without generating some of those events properly. Beyond that, oh, yeah. That is true. And I don't think I have a slide here about best practices in the event system or the reactor system, but you bring up an excellent point. The next thing was concerns over sending sensitive data over the event bus, and that's a very valid concern. And in fact, we went through a code audit a while back, before the last SaltConf, because when we spun up machines, we were just passing all the machine data back to the master of the event bus so that people could listen and pick stuff up. And we went through and explicitly stripped out anything that was sensitive, even as far as public keys. Not just private keys, not just passwords, we stripped it all out. Do not send private data over the event bus. Now, beyond that, in RATE, if you're moving onto that protocol, RATE works a little bit differently. With ZeroMQ, we have a master and we have minions, and the only communication is between master and minion. If you want one minion to talk to another minion, it still has to go through the master. However, with RATE, there's going to be possibilities coming up of minions talking directly to minions. And that will alleviate a lot of those concerns, but I would still be very careful about passing passwords over the bus. If you do have a use case for that, GPG it first or something. Okay? Does that answer your question? At least enough for now?
Well, I mean, the basic question was, has any thought been given to authentication,
controlling the socket?
See which events maybe you don't want some, general user to see all the events going through. You want to see certain flash. In the same way you can limit their ability for runners or things like that. You can limit what they can do through the authentication system.
There is one way to limit who can see the authentication, and this is just another Unix trick, really. The Salt Minion doesn't have to run as root. It can run as any user. When it runs as a non-root user, it's limited to the types of things that it can do, obviously. But if you run it as a non-root user, then the other users aren't going to be able to look at it. And come to think of it, let's take a look at that bus real quick. Var, run, salt, master. So the permissions are such that only the root users are going to be able to read them anyway. So I think you're probably okay. Any other questions? Okay, that was a really great question. Thank you. Okay, so we've talked a little bit about the event system. We can see how messages are passed from minion to master, and you guys know how messages are passed from master back to minion, right? Through salt, just a regular salt command. Okay, so we have bidirectional communication there. So when the events go up to the master is already listening for the events anyway, and so this subsystem was built directly into the master daemon, or daemon if you prefer, so that the master can look at it and say, okay, I see this tag, I want to do this. I see this tag, I want to do this. Very easy to just kick it off into another process and say, go ahead and do this. Okay, so the master picks those up. It uses the master config file to map tags over to SLS files, and then the SLS files are stored in the server reactor. We'll look at those in just a moment. But inside the master config file, we have a reactor stanza. You guys, obviously, this is in YAML. We're all used to YAML by now, right? Or at least we've seen it. If we're not used to it, it doesn't take long in Salt. There's a reactor stanza, then a list of the tag that it's looking for. And you notice in that second example there, SaltCloud star created. So we can use globs in here. In this case, SaltCloud, it fires off, like I said, kind of a lot of events when you create a machine or when you destroy a machine. And all of those events will have a minion ID in them of the machine that's being created or destroyed. You'll notice, too, that it's salt/cloud. If we hop back over and look at the events that were fired here, no, come back. We have salt/job/something. This is what I mean by namespaced events. Things that start with salt, they belong to salt, some sort of salt subsystem, and then it breaks off into other systems after that. You guys are probably going to want to separate your tags the same kind of way. You'll notice that they're separated by slashes. Did anyone expect to see dots there? Did you? And in fact, the first iteration, we had dots there. When Tom and Sam, Sam's not here this week, unfortunately, but when Tom and Sam were working on this, they came to me and said, hey, I need you to generate some events in SaltCloud, and they need to have the Minion ID in there. And I started putting it in there, and I came back half an hour later and said, hey, my Minion IDs are fully qualified domain names. So we need something different. And they said, oh, crap, you're right. Everyone does that. Okay, let's go ahead and change that over to slashes. So that makes a little bit more sense why they're slashed. Now they're fully qualified path names, and if you have events referring to direct paths on your system, I can't think of a good use case for that, but that's because I didn't think about it till 5 seconds ago. However, that's just what Salt uses internally, and we don't have an internal use case for paths. If you want to, I mean, they're your events. Set them up however you want. If you want to use underscores, use underscores. If you want to use basically any character on your keyboard, use them. Just make sure you stick with ASCII characters, okay? No using kanji. No using any other kind of Unicode. Keep it to ASCII for the tags. The data doesn't matter, okay? In fact, the data can be binary data. But the tag does need to be an ASCII tag, okay? So you guys can see how they're namespaced out there. Let's hop back over to the slide here. We can see that in this case, we have a reactor set up called newinstance.sls that it starts up every time somebody uses SaltCloud to create a new machine. And it doesn't do it until the machine is actually created. If you go inside and look at SaltCloud, you'll see that there's creating a machine. You'll always see first a tag that says creating. And then you'll see a tag that says requesting. Creating means, okay, I'm starting, I'm into this create function, I'm going and start creating this. Requesting means now I'm going to send a message to the cloud provider requesting that an instance is created. And then usually you'll see something like querying, which means I have an instance ID, and I'm going to keep on asking the cloud provider about that ID until it gives me an IP address. And then it's going to say, waiting for SSH, and it's going to keep on querying the server until SSH is available, and so on. And the very last thing it fires is created. And so at any point in that path, if you're watching the event bus, you can see the status of a machine being spun up. And if you want to kick something off after it says querying, which means we have a machine that's being requested, and we want to just kick off something else that's watching that machine somehow, we can do that. Maybe if you've tied in something to one of the Bodo utils that Ryan Lane has put inside the execution modules and kick off something that turns on monitoring somewhere or modifies the monitoring. Those things are available to us. In this case, one of the first reactors that I set up, ever actually, it was, maybe it's not a great use case, but serve reactor, what did I call it? Cloud alert .sls. This is just when somebody spins up a new machine, meaning something that I'm about to get billed for, I want to know. And in fact, maybe my IT team wants to know so they can go and do things about it. I mean, it's probably a perfectly valid request. I hope it's a perfectly valid request. If it's not, then again, they'll get this alert through PagerDuty that says, hey, there's a new instance that's been created. And there's another one there as well on this system for destroying a machine. It also fires something off and says, hey, one of your machines just disappeared. So those are a couple things you can do. We'll go into simpler ones, then we'll go back to this one and take a look at it. Okay, so there's our master config. By the way, since this is a master config item, once you've modified this, you do need to reload the configuration on the master. You don't have to put it directly inside the etc salt master file. You can make another file inside master.d. That directory is available. Be careful because this is a top-level declaration. This is YAML we're talking about. So what's going to happen if you put something inside here and then put something inside the master.d directory that also has a reactor stanza? One of my students tested this a couple days ago, and apparently the one in master.d wins. So I think he may have filed a bug to have them merge together or something. But yeah, keep it in one place, and master.d is probably where I'd keep it, just so that I don't have people monkeying around in the master file. Yes?
It's a great feature, but how do you prevent the master from getting blown out of the water from massive amounts of events?
From massive amounts of events? That goes into just dealing with massive events on the master anyway. Tell you what, do me a favor and ask me again towards the end. and we'll talk about ways to mitigate load on the master, because that's really what that discussion is. But that's an excellent question. The question being, how do we keep the master from getting overloaded with events? Yeah, remind me when we get to the end. So we reload the master. We've got the mappings available. That's not the actual SLS file, though. There's 3 types of functions we can put inside the SLS. We can run execution modules. We can do runner modules, and we can do wheel modules. Some of you that may have been in the other talks may have seen that there's other subsystems that also support a state module. And you'll notice the reactor doesn't, or does it? Does it? Because state.highstate, state.SLS, those are all execution modules anyway, right? So the state system is also available. You just need to call it through the command module. So in each of these, it's just going to be command or runner or wheel dot the name of the module dot function, and you guys know how to run the module dot function already. For instance, command.run, command.apache.restart, command.package.install, and so on, right? So an execution command, this is actually probably the most complex of the commands, but this is also the one that you're going to be using the most often. The other ones are a little bit simpler, and we'll talk about why. First off, this is YAML, so we give it an ID, the top level declaration of the ID, new instance alert in this case. And we're doing a command.pagerduty.createEvent. There's also, at the time that I put together this set of reactions, there wasn't a runner module, but there's now also a runner.pagerduty.createEvent. But since this is an execution module, we have to give it a target, someplace to execute whatever this command is that we're running. And we can also use a target type if we want, TGT_type. That could be a glob, it could be IP range, it could be pillar, grain, stuff like that, right? Things that we normally target with. And then there's a couple different ways to do this. You can use a kwarg, or you can use args, okay, an arg. You guys know what a kwarg is? I ask this a lot, and people always shake their head no. Some people say yes. It means keyword argument. It's a key value pair, right? Does that make sense? If you see arg, that means that there is no keyword argument. It's just an argument, which means the module is expecting things to appear in a certain order, and you better give them in that order. And a lot of us, when we use Salt, we use args without really realizing it. When we say package.install httpd, we're giving it an arg. If we say package.install package equals httpd, that would be giving it a kwarg. Does that make sense? Okay, so we give it a set of kwargs, and make sure you call it kwarg and not kwargs. The reason it's called kwarg here is because we're in Python, and kwargs is it's special. So call it kwarg here. Okay. That code would be really confusing to read if we called it kwargs as well. As far as runners are concerned, runner.module.function, we can do kwargs, we can do args. You'll notice that there's no target, though, and there's no target type, because runners run where? On the master. Execution modules run on the minion, runners run on the master. How about wheels? You guys know where wheels run? I know you do. You don't? Okay. We'll get to that in just a moment. But we have, again, we have a kwarg set. We can also pass args to runners. And, well, it looks pretty much the same as before. I want to point out, too, while we're here, this was in the other one as well, data name. Do you guys know Jinja? I know some of you do. Who doesn't know Jinja? You'll get used to it enough if you use Salt enough. Trust me. Jinja is a templating toolkit. It allows us to, in this case, it allows us to take the information from that payload, the data that we sent through, and refer to it directly inside our Reactor SLS file. In this case, there's a name that's passed to it from SaltCloud, and it's inside the data dictionary. Those double curly braces there just means that we're going to replace whatever's inside of it with the value of that variable. So in this case, description is, I made it really short. It's just the name of the machine. You guys remember over here looking at this guy? It's actually quite a bit longer. Well, the details are longer. The description is a lot shorter. But we merge in information about the machine, and it gets rendered out to the master. Okay. I want to make a note on this too. This is PagerDuty we're talking about. Anyone have PagerDuty? A couple of you guys do. PagerDuty, it's designed to send pages, right? But they're really cool, and they can send emails or SMS or even give you a voice call. And have any of you guys ever gotten a massive page, SMS page, that you have to scroll through to figure out what's going on? We keep them short and sweet, right? Make them simple. Okay? So that's the deal there with the braces. Let's go over and look at wheel commands. Make sure that we're clear on wheels. Wheel is it's the subsystem that is used internally by Salt to manage the master. So wheels are always going to run on the master. Okay? Unlike runners, which were originally designed as a scripting method for execution modules, who here knows Bash? Or, yeah, most of us know Bash, or CSH, or some other scripting language. Runners give us a scripting language to use for execution modules. Unfortunately, for some people, that scripting language is Python, and it is only Python. There's other ways that we can get around that. If you guys want to talk to me about the orchestrate runner later, we can go over that and other ways to get around it. But anyway, the wheel system is designed to manage things on the master. The thing that most people are going to be managing are salt keys. And the two things that are probably going to be used most here are key.accept and key.delete. In fact, if you guys look at some of the cloud reactors that are out there, they have a wheel.key.delete for when for instance, the EC2 autoscaler shuts off a machine. We don't want to junk up the master, so we just automatically delete the key. Okay? And again, we see that we've used some Jinja here to merge in the name. Okay? So, end of my slides, so I'm going to go over to the examples here, talk about this one's a lot more complex, like I said, just because the PagerDuty stuff requires a little bit more. So let's look at, I put one in here called My Reactor. It's a lot simpler. First off, you can see that I've used an arg instead of kwarg. I've given it whatever name. In fact, in the reactor system, the ID is whatever. It doesn't even matter. In the state system, it's important because you might have IDs referring to other IDs. But in the reactor system, it's just a placeholder. It's just saying, this is here, right? And then we have the next line down. In this case, just command.run because we're all used to these command.runs anyway. We've given it a target. We're just going to run it on TechHat Master because that's the only guy that's up right now. And then with command.run, the first arg we give it is just the command we're going to run. So let's go ahead and run that. Well, let's take a look at the master config too. I want to make sure you guys can see the mapping that's in there. Tag for my reactor is the tag that we're looking for. And then it's going to call out to serve reactor, myreactor.sls. You guys can see my other cloud alerts in there as well. So those are all active. So there we go. This is the event that I've set up, and I've done a really simple data structure there again. Tag for my reactor. Do you guys remember what the reactor is going to do? Temp some file, right? And in fact, if we go and look in /temp, it's not there. Nothing up my sleeves, right? So we fire the salt call there. It comes back and it says true. I know you guys can't read it because it's yellow, but it says true. And we look inside /temp again, and there's our sum file. Let's take a little bit more advanced look, because I know you guys really dig that, right? Getting into advanced subsystems, and I apologize that the font is so big, because this is a time when small fonts are better. So in this window here, I have the master running in debug mode in the foreground. So we'll go ahead and scroll that back up. We'll hop back over and issue our fire event again, and there we go. There's the window. You guys can see the event stuff coming through. We can see that we're sending event, data equals, fun args, touch some file. We can see actual specific event coming through on the master side event as things are happening. So if you guys are troubleshooting, this might not be a bad place to look, is running the master in the foreground. Do it in staging or QA environment, please, not production, because this is going to require stopping the master and then starting it in debug mode, right? You guys know how to run the master in debug mode? Just to make sure that we know how to do that, saltmaster-l debug, right? Or if you really want to get fancy and have way too much information, then -l trace. That's generally way too much. And in fact, trace, I forgot your name already, but I know you're with Redbook, Tom. So Tom, trace mode frequently shows passwords. So keep that in mind. So we could do trace mode. We're just going to do debug. Get that guy up and running again. We can see all the other bootstrapping that it has to do. I've also got the Minion over here running in debug mode. Started up exactly the same way. Salt Minion-l debug. And let's hop back over here and issue my event again. It's going to hit the master first, and it's going to go down and hit the Minion. And we can see some events there about firing. It's not nearly as much information. In fact, what it cares about, there we go. It cares about the job that's being done. And then when it's done, yeah, there's the fire master up there. So it fired master, it went up to the master, it fired something, it went down to the Minion, it kicked off the job. There was a bit of a delay because it had to hit the master first. There's the job that it actually asked for. And then if we were actually watching these two windows next to each other, we'd see this dance, scroll, 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 because these things are talking to each other, right? So some interesting debugging there. Okay. Okay, I don't know that I have much else to say about this specifically, so I'm going to go ahead and open it up for questions. You, sir, yours is still not specifically an event question, so I'm going to ask for a couple more questions first, and if nobody has questions, I'll come back and talk about handling load. Does anyone have any other questions? Sir. Oh, yes, thank you. Let's be more specific about that. So we'll do something simple. We'll say ice cream, strawberry. Okay, so we've got a key value pair that we're passing through. This is syntactically correct JSON, which also means it's syntactically correct YAML. I mentioned this a couple days ago. You would do it through the Python API. If you could do that from the command line, by all means, go for it. I haven't done that from the command line. I have done it from the API. Okay, so we're going to go ahead and fire that. We'll hop back over to the event listener and see what it looks like specifically. There's the last thing it did. Let's scroll up and look for the thing we actually care about. You know what? Let's scroll this first, so it's easier to find. Okay, so we'll go up to the top there. We did our auth, so it's checking with the master. Another auth. There we have the tag, and then we have the data payload there. Ice cream is strawberry. Is that what you're looking for? Okay, excellent. Thank you. I was going to bring that up, and I spaced it. Anyone else? Yes? Did you say that the amount of data that you put in there is unlimited? There is no imposed limit.
So any minion potentially sends as much data as possible to a master?
Yes. And then the master would have to have some way to deal with it. And yes, I have played with some file system operations doing exactly that. There's better ways to do it, by the way. And in fact, if you're interested, inside the file execution module, there's a seek read and a seek write, specifically so that we don't have to do stuff like this. It is a good way to bring down a master from a compromised minion. And I don't know of a good way to mitigate that specifically, other than protecting your minions. What's that? That would be an excellent idea. Or some way to detect the size of the payload that was received so that it could fire some other alert. If one of you guys wants to file an issue that recommends either imposing a payload limit or monitoring the payload limit so that we can react based on that, a warn limit and a hard limit would be great. So thank you. That's a really good question. You remember Tom was talking about how users help us innovate, how users affect us? This is an excellent example. So yeah, if you could file that, and we'll take a look at it and bug Tom, because that's a very excellent point. So we've moved on to performance, so I'm going to come back to your question here. Things to deal with performance on the master. First off, if you have a lot of minions that are doing legitimate traffic that is quite large on the event bus, it may be a good time, if the master starts to fall down, it may be a good time to start setting up a syndic system and have these minions report to this syndic and these minions report to this syndic, and have them start distributing a load amongst themselves. This is not a question I've gotten before because most people are not making really heavy use of the event bus like that. Most people are trying to send small, simple messages that just kick off other reactions and have them do things. That's probably the first thing that I'd go to. This guy's, I didn't catch your name. I'm going to say Daryl. Daryl and Daryl. His comment about payloads that are too large from a compromised minion, that's another thing to look at when we get to that point. And I think that's something that should be a higher severity too. So in fact, CC TechHat on that to make sure I get it. Thank you. I could go into, thank you. I could go into a lot of details on mitigating load. Is there anything more specific that you're interested in? I'm not sure on the event handling. The reactor handling, I believe, is a separate thread. At the moment, I think it's only one thread, though. And that brings up another good point. Now, the reactor system, Reactor SLS files, use the same rendering system as the rest of Salt. And so any renderer that's available in Salt is also available to the reactor system. And that means you can have some very complex renderers written in things like Python. In fact, let me see if I still have it open somewhere. I don't. I bring up this reactor a lot because it's got a lot of great examples in it just in general. This reactor is written entirely in Python. You can see at the top there. Let me enlarge that. We've got that hashbang pi that tells Salt to render this in Python. It's just straight Python code. We see we've got a function down here called run that does all the work. The idea behind this is that when EC2's autoscaler spins up a new machine, it fires off a notification to wherever you configure, in this case a webhook, on the Salt master that receives that notification. First it checks to see if it's a valid notification. And if it's valid, then it goes through and says, SaltCloud, I have a new machine. It's called this. Go ask EC2 about it, and do what you normally do, SaltCloud, except for the part where you actually create a machine. Skip that. Here's the machine. Just do all the rest. And so SaltCloud will pick it up and start bootstrapping it. When I originally wrote this, I actually had it call out to SaltCloud during this process, during what would be called the render phase. And that would take, it takes 2 or 3 minutes to spin up a machine and then get Yum to do all the dependencies and install Salt and all that fun stuff. What I did not realize at the time, until I showed it to Tom, was that this happens during the render phase. And like I said, there's one thread handling it right now. And any other reactions that come in start to get queued up. And so the render phase will block. The really complex things like this are going to block. Now this is down to just a few seconds. It has, I think, 2 real web calls that it makes. And then a SMTP call if it finds things wrong with the request that it needs to handle. But it really only takes a couple of seconds to run, so it's not so bad. What I probably should have done at this point, though, is moved all of this out into a runner or move it out into the orchestrator and have it handle that so that this would take a fraction of a second.
15 minutes on each, you know, firewall.
Firewall settings on EC2 and right, and that could really cripple things in the reactor system. I don't think it would affect the rest of the master, but the reactor would be affected by it. And it would just start queuing things up. So that's another thing to be worried about with load. Okay, I'm going to check around and see if there's any other questions. Are there any other questions? Yes. The pre-tag? What are we talking about? I don't know. I will ask about that. Haven't used it. Yes?
Rather than restarting the master, which seems like a precarious thing to do,
Uh-huh.
are you going to support maybe signals to tell the master to reload, let's say, a reactor?
I am under the belief that the wheel system can be used to reload configuration without reloading the master. I don't know how to do it. And that's why specifically I said reload the configuration and not reload the master. There are subsystems that have the ability to do it, and I've never played with them. But I believe that the wheel system is one of those. So take a look at that. Okay, guys, it's 11:30, so I'm going to have to finish up here. But thank you for coming to my talk. I appreciate it. If any of you guys have any questions beyond that, come find me.